Welcome back. In this section, we're going to talk about audio restoration, and in doing so, we're going to try to bring together some of what we've learned about using plugins, with spectral editing, with our error correction tools, and put it all together into one tool set you can use to solve just about any restoration problem. Now, what we've got up on the screen is a piece of soundtrack called Noisy Mess, because it really is. There's a lot going on with this. I'm going to play the dead air ahead of it and then a little bit of the signal, and you're going to notice three distinct problems. Okay, we've got a pronounced hum. There's a lot of clicks going on, and there's a background hiss as well. I'll take one more listen just to the noise here. Okay, so we'll attack those. There's several ways to solve each of those problems now. And just for a second, let's jump over to the spectrum view, and I'm going to maximize this because I want to show you something specific. If we zoom in vertically here, notice that incredibly bright blue line down there. I mean, it's so pronounced and so even that it almost looks like it's not part of the signal, like maybe that's part of the frame on the computer screen or something. That is a telltale sign of electrical interference. Now, in North America, where the wall power, the alternating current, is modulated at 60 hertz or 60 cycles per second, if you get or incur electrical interference, it's going to hang out either at the 60 hertz area or up at 120, at twice its natural frequency. And in most of Western Europe, where the power is modulated at 50 hertz, you'll see those same telltale interference traces, but they'll be at 50 or 100. But what we have here is this is centered around 120, and it's just blows all the way through the entire recording, and it's just so steady and solid throughout. That is a telltale electrical interference signature. Now, you're probably thinking, hey, I know how to do spectral editing now. We could start with our tools and go in here and outline that and clip it and remove it and so on and so forth, and you could. You could certainly attack this that way. But if you start looking in here, there's an awful lot of area where that signal is really intertwined with all the other stuff, and it's complicated by the fact that in this particular piece we've got those sort of temple bells, Glaman bells ringing in the background, right? And so they're long decay and their harmonics are interacting with the same stuff. So to go in, second by second and pull out that 120 hertz line hum, while doable, extremely time consuming, but you could do it. We'll look at an easier way. Along those same lines, I'm going to highlight a chunk of audio in the back here, this tail out, after the piece basically ends. Put our audio editor back down in place there, and let's open the error correction tab. What we're going to see here is a more advanced or elaborate version of the same tools we explored in the process tab. We came down here and had all of this. And here again, you could go, if we zoom in, just using the H key there, and we zoom up vertically. We could come like we did in the piece of violin music with my grandfather. You could go click by click, and you could select something and come down here and say, well, let's try that. Worked pretty well before, and see if that works. I think it got that one click, that sort of thing. Again, like the spectrum editing approach, very time consuming. It would work, but there's an easier way. So let me put this back into perspective, and what we're essentially going to be able to do is grab this whole section of audio, or for that matter, you could grab the entire waveform if you wanted to, and apply those same tools over and over again automatically. So we have 4 tabs in the upper left-hand corner here for detection, correction, the search area, and options. And the first step in this, like we've seen with every editing process, is to pick out what it is you want to go to work on. There's 4 different detection methods here. 3 different detection methods: click 1, click 2, and digital click. There's no magic to any of these algorithms. You're going to have to just experiment with which one does a better job on your source material. Then below that, you have thresholds for volume and for detection width and so on. And essentially, the smaller the pops and clicks you're going after are, the more you can dial these down. If you're going after bigger stuff, you'll have to dial them up. But again, there's a trial and error process for whatever source material you're working with. But I do want to point out down here that you have a preset handler as well. So if, for instance, you're working in an archival setting where maybe 1 month you're being presented with stacks of vinyl albums that you're restoring, and you come through and you set all of these parameters up just right for vinyl, you can save that as vinyl correction. Then next month, somebody's bringing you reel-to-reel tapes that you're cleaning up, and that involves an entirely different set of parameters. You can save those as your tape preset, and over time, you'll have more and more sort of pre-configured settings that you can pull from and fine-tune in less time. Then the next windows should be familiar. This is the correction method, and these are the same tools that we saw down here in that area. And like we saw there, the linear interpolation is what it defaults to, but in my experience, that's one of the least useful. I guess it depends what you're working on, but linear interpolation is going to just take from the beginning of what it sees as the error to the end and draw a straight line across it. Then it's got a couple of preset values for small clicks. We saw what wave replacement did earlier and so forth. So you're just going to have to make a decision about what you think is appropriate. I would say that the smaller the clicks get, the better the linear interpolation method works, and the less background music it has to work around, the better that linear interpolation will work. But if there's a lot of stuff behind the click, that straight line, it replaces a spike with a drop, and you can still hear that something happened. But we'll leave it, that's its default, and we'll leave it set there for now. The third section is your search area, and you can basically have it do the entire file from the cursor or your selected range. And those are the numbers that you see highlighted down there, and that's going to change as I go back and forth. So this is the area we want to go to work on. And then finally, we have some options. And what it's going to do is, if you don't change anything, it's going to put a set of these sort of olive drab markers called error markers around each thing it finds that it thinks is a problem. And then you've got the second option to remove those markers after it's corrected and to autoplay the error. So once we have that all set the way we want to, you can go error by error through here, or you can come over to this macro and say detect all errors. And we've zoomed way in here, and you can see at the top there, we've got a marker around this, and it says click 01. Let me use the G key to zoom us out a ways here. All right. And you can see it found a whole bunch of stuff. I'm going to kind of optimize for that. So we've got click 1, click 2, click 3. It's gone through that whole area and identified them. And then if you decide you want to correct it, you can move on to the next one, or you can say just correct all marked errors, let it do its thing, and then see overall how it sounds. And we still have the hum and the hiss, but it actually did a really good job of getting all those clicks out compared to the beginning here. Okay, so that's essentially how the error correction tools work. And if you, I think ideally you would have it take those markers out after they're fixed. The idea is it's just going to draw your attention to the area that needs worked on. If you, I suppose if you're in an environment where you've got a QA person that's coming in behind you, or somebody else wants to review the changes, you would decide to leave them in there. But in any case, that's primarily what the error correction tab does, is a more elaborate and automated version of that the correction menu that we saw earlier. Now, let's attack that hum next. And there's a couple of ways to do that. Let me get to the spectrum meter first. Actually, the spectrum, yeah, that's going to be the best way to see it. And as soon as it starts playing, I'm going to hit the camera to take a snapshot. Okay. And you can see right here, you're seeing the hum very, very dramatically called out there. And then actually in the upper harmonics here, you can see the hiss and the background noise. So if I put my cursor right at the peak of that, you can see the display above here. Keep an eye to the right of the little mountain icon. And it's saying, yeah, not surprisingly, that hum centers very tightly around 120 hertz. So that's obviously coming from wall power. Now, you could attack this with a traditional EQ, a really steep notch filter, essentially a notch that looks like the upside down version of that wave, and just run the signal through that. But we have some tools built into Wavelab that do an even better job. So let's open the plugin menu and come down to Sonnex. And there are 3 different restoration tools here: the debuzzer, declicker, and denoiser. Let's do with the debuzzer first. And a couple of neat things here. This has a essentially how the controls are going to work here is you've got an input and output monitor left to right. It's got a tracking mode, which is defaulted to auto, and that's usually where you want it. Then you've got big controls for sensitivity, attenuation, and most critically, frequency with a fine adjust. You can double the scale on that to get in even closer, and a freeze mode. But it also has a tone generator down here during playback. So if you don't have a real good eyeball on where the frequency is, you can turn on the tone and then scroll around, and it's almost like tuning a guitar string or something. It'll deadbeat until it's right in sync, and then you've got it nailed down. So what I'm going to do here is just select the range of audio before the music starts and go into loop mode. So it's just going to play that over and over again, and we'll take a look here. And I'm going to start by turning this off. And I guess before we jump in here, there's two modes, buzz and hum, and that just fine tunes how sharp of a waveform it's looking for. Obviously, for this mode, for this example, we want the hum option selected there. And we'll turn it on. Somehow I've managed to leave loop mode. Sorry about that. See if it's going to loop. It is. So at the moment it's not doing much, but that's because our frequency is set down here around 50. Watch what happens as we bring this up towards 120. Okay, you can see it go away and come back. All right, and you can see the reduction meter here. That's telling you how much it's taking out. Now, how far it's suppressing, that's going to be a function of your attenuation control. If we turn the attenuation to 0, we've effectively turned off the effect, and we can smash it all the way down to nothing. But again, like any other inline processor, the more attenuation we apply to this frequency range to kill the hum, the more we potentially interfere with the other stuff that's going on there. And then if you really need to fine tune it, you can come in here and take the fine adjust and scroll even more accurately. Get it right up there to 120, and that's just killed all of it. Okay. And there's the tone generator on and off, and you can see we've kept the snapshot of where the other tone was on the display. So if I turn on the tone generator here, it's laying right over top of the one that's causing the problem. So the debuzzer has that pretty well taken care of. I'll leave this in hiss or loop mode and call up the denoiser, and we'll go after that hiss. And of the three Sonnox plugins, the debuzzer and denoiser, in my experience, work unbelievably well. The declicker can leave some artifacts. It works really well with some program material, less well with others. And since you have the error correction tab available here, my recommendation would be to try and get rid of clicks and pops there, because among other things, you can be a little more surgical about it, and you can leave them alone in areas where the program's masking the clicks. But already, see, this is enabled in when it popped up. Let me turn it off. Okay, and the same sort of controls. You have sensitivity to one side, and then attenuation on the other. And let me run the sensitivity all the way down, well, all the way up, get it out of the way. If you look very closely at the middle of the display here, you can see it's showing you the noise floor, and then it's showing you where the sensitivity slider is. And left to its own devices, it's going to try and lay that yellow line essentially right on the top of the noise. And you have adapt and freeze in here for tracking modes, depending on how constant the noise signature you're after is. And my advice would be to leave it in the adaptive mode. And you can also set a high frequency limit over here, so that again you're keeping it away from a harmonic structure that you might want to prevent changing. And then the last major control here is attenuation, which is how much of the noise will be taken out. All right, so there's back to just almost quiet. Now, the only other question is, these two plugins have done a fantastic job in this looped section where it's only noise. Let's stop the transport, undo the loop mode, and listen through our material. And that's pretty good, actually. So just for a before and after, I'm going to bring us back to the top. I'm going to bypass these two and start playback. Then we'll put them back on. Listen to the final result. Okay, so we've taken what was a really noisy mess and cleaned it up pretty well. Let me just take a moment and to talk about the subject of online versus offline processing. If we go to render right now, we're going to get a warning that since these are adaptive processors, they're artificially intelligent is overstating it, but they need to observe the signal, right, for those live tracking modes and things. And so it's going to take it a little bit to figure out what it's going after and fix it. So if we come over here to the render tab and we say, yeah, let's go ahead and do the whole, sorry, let's do the whole file and start. We get this warning that pops up and says the debuzzer plugin is being used in auto mode. If you render like this, the start of the file might not be processed optimally, etc. So that warning is taking us to a larger issue about online versus offline processing. So in an online processing, whether this is the noise reduction stuff or reverb or whatever, when you're rendering, the computer is actually running the signal through all of those plugins as it's conducting the render. And that can use a lot of CPU power, for one thing. Another thing is some of these plugins where they take a little while to sniff the air before they begin working. It can throw off, it's not going to work as well at the beginning as the end. So there are arguments to be made for taking these plugins and applying them at the clip level and making them part of the audio signal so they're baked in. You can make sure they worked and then render it out after that's all done. And that really is, again, it's going to come down to how well it works in your situation and the material you're working on. In this case, it wouldn't bother us a bit because there's nothing of content value in the first 5 seconds of this wave. So if it took 10 milliseconds for it to come online and figure it out, it's not going to have any impact on our application. But there are other times if you're working on something that's going to be in a sample in a drum kit, and that transient couple of milliseconds is everything, then you might want to stop, go back, apply those, rather than applying those effects in the master section, you might want to go back and apply them to the clip, render them in place so they're locked down before exporting the whole thing. So that's the discussion in the manuals and stuff about online versus offline processing. That's really the core issue involved there. So there's one other tool we want to look at here, and that is the Vox&Go Curve EQ. And it's not, strictly speaking, a restoration plugin per se, but it does have, it gets used that way an awful lot. I'm going to back up here and just review a couple of things about interacting with our work environment as we set this up. If I add a new file group over here, I have the option to split this into two for side by side. And the audio priority, the priority in the middle here, you can set this sort of to bias it. What does it think it's going to get? Or if you just drag, say, audio into this, it's going to turn itself into an audio editor. So all I'm doing is dragging a couple of waveforms off my desktop right into the new tab group, and they're good to go. Now, I will say you need to save this. If you think back to Chapter 4 in file handling, all they're really doing is referencing right now. So if I were to take these, throw them in the trash, and empty the trash, the next time I open this project, these are going to be missing. The next step would be to go in and save this to whatever location that we want to use for the project at hand, right? Otherwise, they'll disappear. But this will be enough for the demonstration we want to do right now. And up until now, we've primarily worked with tab groups or with window displays where we're working with one thing at a time. But don't forget that you can subdivide these into all sorts of different layouts. Now, one other control that we haven't looked at yet is this funky box off to the side where it says activate, deactivate, file tab checking. And all in the world that does is add the checkbox and the close box to the tab over there. So with that unchecked, the problem is how do you get rid of this thing? How do you move it around? You don't really have any good handles on it. If you enable that, then you can close it and select it and handle it. It's by unchecking that box, it's kind of locked into the workspace. It's all in the world that really means. So okay, we've got our two waveforms up here. I'm going to come back over to the master section, and we're going to drop in the Vox&Go Curve EQ. And this was, I think, all the rage back in version 7. If you haven't worked with this thing, it's a great EQ generally. I mean, you can do all kinds of neat stuff with just drawing, spline EQs, so you can make it as elaborate as you want to. You can have multiple curves up at the same time and so forth. So it's a very, very powerful EQ tool, but its claim to fame is it can copy the EQ off of one piece of audio and then apply it to another. So you have a source and a destination. And that's why I say it does get used in a pseudo restoration type role as often as not. So if you have, I think the last time we used this, there was a guitarist who had done performances on 2 different days, and there were slight EQ differences because of the mic position and seating and humidity and whatever else. And to try and get a more even tone, we were able to lift the EQ curve off of the first day's stuff and use it to process the second day's. It's a real specialized tool, but the key here, so the rest of the basic EQ stuff is pretty understandable. We'll skip to the good stuff, which is here under the matching mode. Move this guy off to the side. And so we have a bunch of different spectrums here. We're going to use the take and the apply to and the match spectrums. And the first time you're using this, I want to point out, is you hover over a control, look at the bottom of the window, and you're going to get a great play-by-play of exactly how to use this. And so the other key mode here is your spectrum mode. And for the EQ curve matching, you want to bring this down to the average setting. And then we're going to let this, the source material here, I'm just going to make the one on the left the source and the one on the right the destination. You need to let it loop long enough for the system to absorb the EQ curve that's going on there. So I'll start playback. Okay, so when I hit the take button, a bunch of stuff turned on here, and we haven't given it a name. You would call this source or good day or bad day or whatever. And it gives you some specifics about the stuff you're listening to, but most importantly is the time. We let it sit there and average for 10 seconds, and they say that's about the minimum to get this to work. All right, so then what we're going to do is come over to the second waveform and let it loop for a little while. And this is why I decided to put the 2 windows up side by side. When you're doing a lot of A/B stuff or copy-paste stuff, it's easier to have the 2 windows up simultaneously. All right, so now we have 2 spectrums that have been sensed, and you can see them overlaid there in the 2 different colors. And the key then is to determine which one of them is going to be the reference and which is going to be the apply to. So if we take the first one and say, yep, that's the one we really liked, we're going to use that as our reference. We want to apply that to the second one. Now we have our A/B setup ready to go. The only other thing we have to do is hit match spectrums. And it's going to generate this curve based on applying the one to the other. But you can see this is fairly blown out and extreme. It's not going to actually sound good, but here's what it sounds like. Okay, so it picked up a lot of that thuddier, woodier, low-end stuff. Okay, one of the problems we run into from time to time making these videos is massive system failure. So we're back from a pretty dramatic crash. But just to finish up here, what I was trying to show you was that if you're getting a curve match that's just way too dramatic, one approach is to back off of these sliders, move those faders a little bit further to the left, both during the take and then during the matching process. And then just like all the other sort of magic boxes we've looked at so far, you're never going to get a one-click perfect fix. You're going to have to come in here and make manual adjustments to it. And you can do that by double-clicking or single-clicking to add and remove nodes. You can drag them around, add modifier keys to change the curve associated with them, and so on. But it'll get you a real good starting point for how to come close on the 2, making the 2 sound similar. So don't forget that the curve EQ and its matching function is in there as a restoration or as a fixing tool as well. And with that, we'll wrap up this section and move on to the next.